Look at these two diamonds side by side. One came from deep underground. The other was grown inside a machine in China. Same crystal structure, same chemistry. And to the naked eye, they can look virtually identical. Specialized equipment can tell them apart. But for the diamond industry, that hardly solves the bigger problem. Because one of these stones took nature billions of years to create. The other can now be grown in weeks, and the price difference is enormous. 20 years ago, Zhejiang County in China's Henan province was better known for agriculture than high technology. Today it sits at the center of one of the world's largest synthetic diamond industries. China now produces most of the world's synthetic diamonds, and Zhejiang accounts for a huge share of that output. But here's where this story gets strange. China didn't originally build this industry to sell engagement rings. It built it because factories needed something much harder. And decades later, that decision would help shake one of the world's oldest luxury markets. But jewelry may only be the beginning. Lab-grown diamonds were once expensive, but as production improved and factories scaled up, prices began falling fast. By 2018, a 1-carat lab-grown diamond traded wholesale for around $1,800 per carat. By mid-2026, comparable stones were trading for around $80. That's a decline of more than 95% in less than a decade. Meanwhile, lab-grown diamonds kept gaining ground with consumers, especially in the United States. And that created a serious problem for the traditional diamond business. For generations, diamonds had been sold as something rare, something nature could only produce in limited quantities. Now factories could make the same basic material again and again, and every time production became cheaper, the old idea of scarcity became harder to defend. Which raises an obvious question. Why were diamonds so expensive in the first place? In 1888, Cecil Rhodes helped create De Beers in South Africa. Over the decades that followed, the company gained extraordinary influence over the global diamond trade. At its peak, De Beers controlled the vast majority of the world's rough diamond supply. That gave it enormous influence over how many stones reached the market. But controlling supply was only half the story. The industry also had to create demand. In 1947, an advertising agency working for De Beers introduced one of the most successful marketing slogans ever created: "A diamond is forever." The message was simple. A diamond wasn't just another stone. It meant love, marriage, commitment, limited supply on one side, emotional demand on the other. For decades, that combination helped support one of the world's most valuable luxury markets. Then technology changed the equation. The pressure is now easy to see. In 2023, De Beers reported underlying earnings of $72 million. In 2024, that became a $25 million loss. Then in 2025, the loss widened to more than $500 million. Lab-grown diamonds aren't the only reason. Demand for natural diamonds has weakened too, especially in China. But the rise of cheaper lab-grown stones has added even more pressure to an industry already struggling. And ironically, much of that pressure can be traced back to China itself. Not to a diamond mine, but to factories in the middle of Henan province. China produced its first synthetic diamond in 1963, but those early diamonds weren't designed for jewelry. They were tools. Diamond is incredibly hard, making it valuable for cutting, drilling, grinding, and polishing materials that destroy ordinary equipment. As China's industrial economy expanded, demand grew with it, Henan province became one of the centers of production. Factories there spent decades improving a process known as HPHT, high pressure, high temperature. Carbon is placed inside a powerful press where extreme heat and pressure recreate conditions similar to those deep inside Earth. Instead of waiting for geology, engineers control the process inside a factory. For decades, much of the output was tiny crystals, powders, and abrasives. Nothing you would put on an engagement ring. But the machines kept improving. So did the crystals. Better pressure control, better temperature control, better manufacturing. Slowly, synthetic diamonds became larger, cleaner, and more consistent. Eventually, factories could produce stones good enough for jewelry. And once producers realized there was a huge consumer market waiting, production expanded rapidly. By 2023, China was producing around 22 million carats of synthetic diamonds a year, accounting for more than 70% of global output according to Chinese industry figures. Zhejiang became one of the industry's most important production centers. That enormous scale helped push prices down. But jewelry is only one reason synthetic diamond matters. Because diamond has another property that may become even more valuable than its appearance. It is extremely good at moving heat. Modern computer chips have a problem: heat. The more computing power engineers pack into a small space, the harder it becomes to keep everything cool. And diamond happens to be one of the best thermal conductors known. That makes synthetic diamond interesting as a heat spreader. A thin diamond layer can help move heat away from the hottest parts of an electronic device. Diamond materials are already used or being developed for high-power electronics, semiconductor systems, lasers, sensors, and other specialized technologies. And there's another use. Tiny defects inside diamond crystals can create extremely sensitive quantum sensors. These can measure incredibly weak magnetic fields, with potential uses in medical imaging, navigation, research, and advanced electronics. Suddenly, the same material people wear on their finger looks very different. It isn't just a gemstone, it's an advanced engineering material, and China controls a huge part of its production. Then, in October 2025, China made that advantage more important. Beijing announced new export controls covering certain artificial diamond products. That included some diamond powders, single crystals, specialized tools, and technology used to produce super-hard materials. From November 2025, exporters needed government licenses for controlled products. China wasn't banning every synthetic diamond from leaving the country, but the rules gave Beijing more control over who could buy certain forms of the material and the technology used to produce them. And the timing mattered. Diamond materials have potential uses in semiconductors, precision manufacturing, advanced electronics, quantum technology, and military systems. By 2026, Chinese diamond companies were reporting growing interest in high thermal conductivity products for chip cooling. The industry's center of gravity was beginning to move from jewelry stores toward technology. And that's what makes this story bigger than diamonds. For more than a century, people thought of diamond as a rare luxury material. Then humans learned how to manufacture the crystal, then make it larger, cleaner, cheaper, and at enormous scale. The jewelry industry felt the impact first. Even the GIA changed the way it evaluates lab-grown stones in 2025, replacing its traditional natural diamond grading terminology with broader categories. That doesn't mean natural diamonds suddenly have no value. people may still pay more for rarity, origin, history, or simply because a stone formed naturally beneath Earth. Luxury has never been based on chemistry alone, but industry has discovered something much bigger. The same factories disrupting the jewelry market can produce materials for some of the world's most advanced technologies. That's why Zhejiang matters. Not because China learned how to make cheap engagement rings, but because it spent decades building an enormous manufacturing ecosystem around one of the most unusual materials on Earth. And diamonds may not be the last example. China has already built enormous manufacturing capacity in solar materials, batteries, rare earth processing, and other strategic industries. The pattern is worth watching. Improve the process, build factories, scale them aggressively, then keep making the product cheaper until the economics of an entire industry change. 20 years ago, Zhejiang looked like an unlikely place for any of this to happen. Today, it helps supply the global diamond industry. Tomorrow, its most valuable diamonds may never appear in a jewelry store at all. They could end up inside chips, sensors, lasers, or the next generation of electronics. So here's the question. If a lab-grown diamond has the same crystal structure and chemistry as a mined one, does being natural still make it worth thousands of dollars more? Or are we really paying for the story behind it? Let me know in the comments. Because this story isn't really about diamonds. It's about what happens when technology turns something scarce into something we can manufacture. And when that happens, an industry built over a century can change in just a few years. If you enjoyed this video, don't forget to like and subscribe for more stories about the breakthrough technologies shaping our future. Thanks for watching, and I'll see you in the next one.